Hello, everyone, and welcome to another episode of DABCC TV, sort of, and DABCC Live all at the same time because we have Citrix here, and we're going to do sort of a webinar / video. We're actually recording this versus doing it live, so it's not really a DABCC Live. It's more of a DABCC TV, but it is a webinar. So, unfortunately, it's not live, so you guys won't have the ability to ask questions as we go through here. But what we wanted to do is actually get this thing recorded, get it out to you, let you guys watch it in your own free time, and then email me questions. So if you have any questions for Peter, our guest today, and I'll get to Peter here in a second, please email me, dbrown@dabcc.com, and we will take as a follow-up to this webinar / podcast / video, we will do a audio podcast answering your questions. So this is going to be a lot of fun. So thank you all for attending. Today we're going to talk about one of my favorite subjects, client virtualization, client-side hypervisors, and in particular the Citrix XenClient solution. So we have Peter Blum here with us, and Peter is the main guy in charge of the XenClient solution. So Peter, thank you so much for taking the time to come on the show and do this webinar for us.
Oh, thanks a lot for having me, Doug.
I'm really excited about this. So I'm going to sort of just shut up. I've already rambled a little bit too long, and I'll just let you go through this, and you might hear me sort of ask you a few questions along the way, so I hope you don't mind. And definitely, guys out there, as we're going through, as Peter's going through this, if you have any questions, write them down, email me at the end, and then we're going to put together, again, a really nice podcast for you guys answering your questions to Peter and to Citrix about what they're doing with XenClient. So with no further ado, Peter, it's all yours.
All right, I appreciate it. Great. So today I want to do a kind of quick overview, talk about the use cases that we're attacking with XenClient early on here, and then talk through the different components, XenClient, the Synchronizer, this thing called the receiver, and then we'll drill down into those components and get into the kind of technical details. And at the end, I want to update you on what's new since our RC1 release that we did in May at our Synergy show. We've got some new exciting capabilities that I want to highlight for you. So what we've done, you'll see with the announcement, is we've included the XenClient technology under the Citrix XenDesktop umbrella. And so for a while now, we've had with XenDesktop the ability to deliver different types of desktops to different types of users. And so at Citrix, we have this fundamental belief that there's not one size fits all when it comes to virtual desktops. So we have a variety of different technologies that allow you to deliver the right kind of desktop to the right kind of user. I think one area where we've sort of had a hole before is folks that are enterprise laptop users that spend a lot of time, disconnected, or they're moving between connected and disconnected states. We had some offline application streaming technology that helped us there, but now, we're excited about XenClient. It fits right into XenDesktop and allows us to actually take a virtual desktop and run it locally on the laptop and allow you to run it both offline and offline. So that's the local VM technology, and it leverages client-side compute. And you'll see the other technologies we have here with streaming, which is great for when you've got a corporate environment with systems connected to a LAN. You can have a central image and stream those out to a bunch of systems. Hosted VDI, where you take a virtual machine and run it in the data center and allow people to remotely access it. And then hosted shared, that's actually using our XenApp technology that's part of XenDesktop to allow you to get really high ratios of users per system by using a common desktop. So those are the different models. We're going to focus on local VM with XenClient today, but wanted to kind of give you a sense of where this fits in the grander scheme of things with virtual desktops from Citrix. So, one of the things before I came to Citrix and XenSource, which is how I came into Citrix, I worked in the desktop and server management space. And so, I came from this world of having to help customers manage laptops and desktops, and laptops were always the worst thing to deal with, and they continue to be that way today. Not much has changed. The laptop users have some pretty unique requirements. They want to be able to work anywhere at any time, and that's one of the benefits is that you can get more productivity out of a user, right? They go home or they're on the road, they can still get work done. And they shift between these connected and disconnected states. So you can't assume that they're going to have a network connection. So that means our more traditional desktop virtualization technologies where we're remoting you to a session aren't going to work. and they want really high performance, right? Usually these are folks in the field, they're sales folks. They tend to be higher up in the organization. And they also have the need to install the applications they need. Sometimes they're on the road and they want to have personal applications, or they have legitimate needs to install departmental applications that might not be totally IT blessed, but they needed to do their job. And then everyone dreads going through the scanners at the airport. No one wants to carry multiple laptops, so people really want a single corporate-owned device that allows them to get their job done, but also use that device for personal stuff. They're on the road, they want to check Facebook or edit their photos or videos or do all sorts of things. Their personal life they want to be able to do without having to carry another laptop. And then we also have a set of folks that are out in the field and even internally that need to have multiple operating systems running on the same laptop. That might be because of development and test, or consultants that are working with different customers, or even sales and marketing folks that want to do demos where they have more complex demos, or they have multiple environments running on a single device. So there's some of these are the unique requirements that we're looking to meet with the XenClient and XenDesktop solution. And IT's got some pretty big challenges with supporting laptop users. The biggest one is the corporate data, walks out of the office. One of the nice things about centralizing with, some of our other virtual desktop solutions is that you pull the data into the data center. And so as we design this solution, we made sure that as we move this data back out to the laptop, we wanted to make sure we kind of put a cocoon of security around it. So even though it's back out on the laptop, it's not going to be at risk. We've all seen the articles about someone who leaves a laptop in a train station or an airport, and it's got critical corporate data on it. The amazing thing is most laptops today are still not using disk encryption. So you can walk up in a matter of minutes with a live CD, and you can start pulling data off these boxes. The other thing is security policies are often compromised due to personal use. So a lot of times when you talk to customers and you're asking about, who in your organization has local admin rights on the images, or who has the ability to install their own applications, it tends to be predominantly, the mobile users. And sometimes it's a legitimate need to install things, but a lot of times it's just personal apps and data. And they want to give those users that flexibility, but not affect the backup or the corporate environments. And then backup policies are also pretty difficult to enforce. I see most of the time when I talk to customers, backups for their mobile and desktop users consist of storing things on, file shares. And for the mobile users that aren't in the office a lot, or they're using VPNs, they're not very good about copying stuff up. It's kind of a pain. It's a hassle. If it's not running automatically, people don't tend to do it. So, there's this problem where people don't back up their data, and when they do back it up, it's not an easy process. And then long recovery times when devices fail. So even if you have some sort of backup system in place, your laptop dies out in the field, and you're usually out of luck once you get back in. It takes a couple days to get back up and running. IT has to image the device, and then hopefully they've got your files. They restore your files. They got to install some apps and patches. It can be half a day of their time, a day and a half, really, to get back where you were before. And then user personalization tends to lead to support calls. So I talked about security policies being compromised, people installing their own stuff. That causes a lot of break-fix calls to the help desk, people installing stuff they're not supposed to, or the system's open so malware can get in there. So those are some of the challenges, and I think when you look at sort of these, there's these conflicting needs between the laptop users who want a lot of flexibility, they want to be able to make personal use of their systems. At the same time, IT wants better security and better control of these corporate laptops, and so we really think, and our customers have told us, we've really hit the nail on the head with a solution that gives users the flexibility they're looking for, while at the same time giving IT more control and security. And it's sort of unique, we think, with the solution. Usually you come out with a solution that gives IT more control. It's generally taking something away from the users. But here we have something that delivers for both these groups. I wanted to talk quickly about the use cases, and then we're going to dive into the components and the technology. So the two main use cases we're going after here initially, with the end-to-end solution, which is XenClient, the client virtualization software that runs on the laptop, and the Synchronizer, which is sort of the back end that's part of XenDesktop. The goal there is to provide desktop virtualization for corporate laptops. So really extending, the benefits we see with desktop virtualization to the last mile of users, the folks that are connected and disconnected, giving control for IT while at the same time flexibility for users, allowing for fast deployment of new virtual machines to new employees or contractors as they come online. Some of the technology we have allows you to actually deploy environments cleanly over the public internet, for instance, something that you can't do with a lot of the traditional, imaging solutions. And then self-service recovery to any XenClient device. So, building a nice system for backup and then very quick recovery, and recovery not just to the hardware they were on, but, even totally different hardware. And then the ability to secure corporate data, to protect it as it's out in the wild, and also to back it up centrally so you have a copy of it in case anything goes wrong. So that's one case, is using it to extend desktop virtualization to corporate laptops. And the other one is really looking at running XenClient, standalone without the back end, and that's running multiple desktops on a single corporate device. So, multiple roles, but each in their own secure, segregated operating system. So it could be like, IT professionals that want to run their admin environment where they have, all their consoles and free access, and they also want to run a test environment for maybe new applications they're looking at, and then also a user environment. So if they have to do troubleshooting, their environment where they do their daily work probably isn't going to match what the user has, but they can actually pop up and have an exact copy of what the users have. And then test and development. So folks that, have the need to run on multiple operating systems or different flavors, different languages, they can do that on a single device. We've seen a lot of people have multiple, a lot of development folks have multiple systems under their desks for this stuff, and they can consolidate down to a single machine. And then business and personal, of course, which I'll talk about a little more. And also in some high security environments, we have folks that actually want to run multiple security domains. So either they're connecting to different types of networks, or they have different levels of security. And today a lot of times they're running, again, multiple actual physical desktops, and this allows them to consolidate down to one system. And then multiple system demos. It's like the field folks, consultants, sales, marketing that want to run these complex demos without lugging around a bunch of equipment. So I wanted just to drill into business and personal a little bit more, because that's one of the things we see comes up quite a bit. And the idea here is to run, and it could be both. Generally, it's, people are looking at doing this with Win7. So 2 copies of Win7. One is the business image, and it actually allows, by having 2 environments, IT can really lock down that business image. So they can take away the local admin access. They can disallow local app installs. They can very tightly manage this environment to the fact where you're only allowing kind of corporate approved applications to be installed either through existing systems management tools or through something like XenApp delivering XenApp or AppV packages. And it allows you to have better SLAs, faster recovery when there's problems. So you really lock down that business image, which a lot of IT folks are looking to do to control the costs and keep people from breaking things. But then at the same time, you give them this much more open sort of personal sandbox. You leave it fairly open. You allow local app installs for personal apps or departmental apps that they might need to install, and maybe some real minimal management like a virus scanner and turning on Windows Update. In this environment, you don't have to provide an SLA. The only thing you might do is allow users to reload a clean image. If they really manage to mess up their personal environments, you can let them delete them and pull down a fresh new copy. And so this is really what allows you to give IT what they want, which is lock down and control and lower the cost, and give the users what they want, which is the flexibility to run their personal stuff, and you do it on the same device. So now let's talk about the solution components. The first one is the XenClient technology itself. So, what is XenClient? It's a Type 1 hypervisor. It's high performance because it runs right on the bare metal, and it's built on 64-bit open source Xen technology. This is the same Xen virtualization technology that we used for 5+ years in our Xen server product. Amazon uses it in their cloud offering. There's a bunch of companies that are using it. And so it's this, rock solid, proven, high performance virtualization technology. And this allows us to run multiple virtual desktops simultaneously on the same device. And I mentioned that, we've been using it in the data center. People have been using it on the public internet and clouds. It has essentially a brick wall between the different virtual machines. So you get completely secure isolation for each one of the virtual machines. So in the previous slide, I was talking about personal and business on the same system. That's a little scary, right, if someone gets viruses or malware. But what XenClient does is it keeps the personal instance totally isolated from the business one. If they completely screw up their personal environment, it's not a problem. It's not going to affect the business environment. And then one of the nice things about the virtualization technology in XenClient, it allows you to have hardware-independent virtual machines. So that means you can create a virtual machine image that will go across your current Dell laptops or next to your Dell's laptops. Or you can move it from an HP system to a Dell, from a Lenovo to an HP, and you don't have to worry about the device drivers. We take care of that in the XenClient layer. So it allows you to have a single image that you can deploy to these different types of laptops that most customers have in their environment. And it also, when you look at recovering environment, it allows you to go, say, originally you were running on a Lenovo, you can actually take someone whose system was lost or stolen and recover them to a Dell or an HP. So it allows you to do recovery to different types of devices as well. And one of the neat things about XenClient is we have this service VM architecture for extensibility. And so let me talk a little bit about that. Service VMs are something that add a shared or unique functionality to the platform or provide some service to the local VM desktop. So think of that as maybe a user interface that an end user interacts with to talk to XenClient, or advanced security capabilities like virus scanning in the platform itself. So instead of having, say, a virus scanner in each one of your virtual machines, what if you could just pull that out, run it in a little virtual machine, and provide that as a service to the whole platform? So you reduce duplication. You also make it a lot more secure because it's not in the actual operating system. You can't attack it. So if you get malware, a lot of the sophisticated malware, they're going to try and turn off your virus protection. If you pull it out of the operating system and run it in the platform, that stuff just can't access it. Other things are like network acceleration or network intrusion detection. You can pull that out and actually put it in the platform. This is all built on the XenClient API set, and we're working with a couple close partners now. We announced a relationship with McAfee where we're building some stuff, and so you'll start to see that next year. And then we'll also be providing a public SDK as well that will allow folks, other third parties, to build service VMs and extend our platform. So we want to be really open with XenClient, just as we've done with XenServer. It's got an open source core, which of course everybody can help work with us, and then we want to open it up with a bunch of different APIs and service VM architecture. And as a proof point, we've actually built a service VM. So the first service VM for XenClient is called the Citrix Receiver for XenClient. And it's essentially a user interface that provides simple wizards for creating VMs locally. It allows you to easily switch between the virtual machines with a switcher bar. And it also acts as a connector for centralized synchronization of desktops. So this is a component that can connect back to the data center, to the XenDesktop system in your data center, to bring down images and do backups. And I'll talk a little more about that in a few minutes. And it also allows for enforcement of local policies as well, like restricting what USB devices you can use, or allowing you to remotely disable and kill the system if it becomes lost or stolen. So that's the job of the Citrix Receiver, and that's one of these service VMs that we have for XenClient. It's a little tiny virtual machine that spins up and provides the services to the whole platform. And then the last component that's part of the solution, this is another part of the XenDesktop solution, is something called the Synchronizer for XenClient. So this is a component that sits in the data center and allows for centralized delivery of virtual desktops down to many XenClient systems. And not only does it deliver the virtual machines down there, it can update a certain class of them. And then for all of them, it can do full-time backup and the rapid self-service recovery. And then it also allows you to do the remote kill and create the policies that I was talking about, like the ability to block USB devices, for instance. So that's all provided by the Synchronizer. So now I talked about the components at a high level. I wanted to kind of drill down a little deeper into the technology behind XenClient and then the Synchronizer for XenClient. So, first of all, I wanted to talk about kind of the install experience. I mentioned that this, runs on bare metal. So what that means is, it's not running on top of Windows. It's not running on top of an existing operating system. You actually install this right on the bare metal. So you go to the Citrix site, you download the software. XenClient's free of charge, by the way, to run on a laptop. So you download it, you burn a CD, you boot the laptop off that CD, and you run through a very simple installer, and then it's going to lay XenClient down on the system, right on the bare metal, and then it'll boot up into that receiver user interface, and then you can actually use a wizard to create your virtual machines. You can stick in your Windows 7 CD and tell us how much memory you want, disk space, and all of that, and it'll actually allow you to install Windows. And it looks, it feels just like a regular machine at that point. But now you have the flexibility of running multiple virtual machines. And one of the nice things is we're working with, even though this is a very simple process, just install and get it going, a lot of folks want to just be able to order laptops with this stuff built in. So we're working closely with a number of the OEMs to actually allow XenClient to be delivered, just as part of the laptop, with the laptop from the factory. Now, if we look to kind of drill down into the XenClient architecture, the way I like to describe this is thinking about a system booting up. So when you hit the power button on the laptop, you go through and, the screen flickers and you get the BIOS comes on the screen. Right after that, the first thing that loads up is the Xen hypervisor. So that's the XenClient hypervisor. It's very thin. It's about 80,000 lines of code. It's the same hypervisor that we use with Xen Server, and as I mentioned, that people like Amazon use for EC2. So it's this nice, mature, high-performance virtualization technology. And then on top of that, we launched something called the control domain. It's this little tiny Linux VM, and that runs some of the device drivers to talk to the underlying hardware. And then we launched another little Linux VM, and that's the receiver for XenClient. That's the service VM that I was talking about. And that provides a user interface. And then on top of that, you load your Windows virtual machines, your personal and business, or your dev and test, right on top of the hypervisor. And you'll notice, this stuff runs right on top of the skinny hypervisor, right on top of the hardware. So there's very little code in between the virtual machines and the hardware, and that's done on purpose so that we can provide not only high levels of performance, but also make sure it's very secure. We know what's sitting in between the virtual machines and the hardware, and it's a very skinny layer of software. Another nice thing about our architecture is it's flexible. So we can virtualize all of the physical hardware. So that means we virtualize the disk, the network, USB, graphics, a lot of power management stuff, so that you can have these images that are truly portable between different types of hardware, different generations of hardware. But what we can also do, and this is using some of the Intel virtualization technology, their VTD technology, we can selectively take a device, a piece of hardware, and actually give it to one of the virtual machines. And we do this for the graphics processor. And that allows us to provide a native graphics experience for a virtual machine. So it means you can play video games, you can do high-def videos, you can take advantage of decoding capabilities when you're watching Blu-ray or a high-def video. You can actually use the hardware to do the coding, which saves battery life. So you get this great native graphics experience using this selective pass-through capability. And the other place we use it is the Intel AMT system. So think of it as, I like to describe it as a management subsystem that lives on your laptop. And we actually have the ability to take that management subsystem and pass it up to one of the Windows virtual machines. Usually it's the corporate VM, and they've got a bunch of great integrations with tools like Microsoft SCCM that allow you to do some really great things in terms of systems management. And the nice thing about this architecture is you can mix and match. You can turn on the pass-through, you can turn it off. You can actually do this without even rebooting the system. So it's some really neat technology. And it's one of the key things that allows us to deliver this really great user experience to the point where, people just feel like they're running a laptop, which is really our goal. We don't want them to feel like this thing's slow or sluggish. We want them to really just feel like it's a regular system, but it's got this flexibility of running multiple environments. Another area that we've done a lot of work, and this is actually a close collaboration with Intel, is around power management. So I mentioned that we're using the same Xen technology that we use in the data center. In that case, you've got the server plugged into the wall. You're not running on a battery. You're not as concerned about power management. In the case of a laptop, when we put the client hypervisor down there on the system, we want to make sure that we're not, draining the battery, right? We want it to have a great user experience, and part of that is how long you can last, when you unplug from the wall. So this is an area where we did a lot of work. The first thing we did is working with Intel, supporting their speed step technology. So as you go from AC power to battery, as the amount of load on the system changes, the hypervisor will actually dynamically work with the CPU to scale it back based on system loads. and that allows us to save on battery. If you need the performance, it'll scale it back up, but this allows us to get better battery run times. And we did a lot of work on virtual batteries. So we actually take all of the battery information and we reflect it into each one of the virtual machines. So that means when you're looking at Windows, you can actually see, it'll show you the battery, it'll show you how much is left, it'll show you if it's charging or you're on AC power. And that's important, so you get all your alerts if you're running low on battery. But Windows also behaves differently when it knows it's running on a battery versus AC power. So we reflect that into Windows, so when you yank the power cable, we actually tell Windows we're on battery, and it'll start operating differently to save battery, and that's important to get us, the great battery life that we get with the system. And then, of course, on laptops, we want to make sure that you can sleep it or hibernate it just like you're used to, so that's there as well. You can just close the lid on your laptop. It'll put your VMs to sleep. It'll put the hypervisor to sleep as well. You can come back the next day, flip it back up, and within a matter of seconds, you're back up and running. And then, of course, all the shutdown and restart stuff that you expect to see as well. So a neat capability that we have in XenClient is something called secure application sharing. This allows you to actually take, say, applications that are running in your business environment and seamlessly display them alongside your personal applications. So one way of using the system is actually flip full screen from, say, a business virtual machine to a personal virtual machine, in which case we replace the contents of the display with that virtual machine. This mode of operation actually allows you to take business and personal applications and view them side by side. So you get this nice seamless display. The good thing is, you get this great user experience, but we still provide total isolation. So we don't allow you to copy and paste. We don't allow you to copy files. We've got it very locked down so you can interact with the app side by side, but there's no movement of data or no risk of malware from one domain getting into the other. We keep it nice and isolated from each other. So that was talking about XenClient, the technology that runs down on the laptop that allows us to run the multiple virtual machines securely isolated from each other. Now I want to talk about the Synchronizer for XenClient. So this is the piece that sits in the data center, part of XenDesktop, that allows you to actually take virtual desktop images and deliver them down to XenClient systems, update them, back them up. It allows you to apply policies, kill pill, lock in the system down as well. So, I talked about how you install XenClient. The way you install the Synchronizer is it's actually a virtual appliance. So you go to the Citrix website, you can download this virtual appliance. It runs on top of Xen Server, which is our server virtualization product, and we have a free version of that as well. And so it's very easy to get up and running. It's about 10 minutes to get this thing up and running. And then what you can do is you can take your existing, any XenClient system with a VM on it. You can just hit upload in the UI, and it'll ask you where your Synchronizer is, and then it'll upload that virtual machine to the Synchronizer. And then you can go in there, and you can just publish it to a set of users. You can say this VM image that I've created is now available to the set of users, either local or you can bring them from an Active Directory. And then the users come in with their XenClient systems, and they can actually get a list, a menu basically, of all the different VM images that are available to them. It might be like corporate Win7, corporate legacy XP, personal Win7. They can kind of choose from the menu of which of these images that they want to download, and it depends on their credentials, what groups they're part of as well. So very quick to get this thing up and running. The architecture, I mentioned it's a virtual appliance. It runs on top of Xen Server. What we've done is we've designed this thinking that these are mobile users. They're not going to be running their VPNs all the time. Most people, don't if they don't have to. So we architected a solution that's secure and designed to run over the public internet. And so all the communication between the client and the Synchronizer is all over a single port, and it's all HTTPS, and it's always the client that initiates the connection. So this allows you to be sitting in your hotel or behind any sort of weird networking and still be able to tunnel through and access the Synchronizer. If you can surf the web, we're able to back up data, apply policies, trigger kill pills. The Synchronizer has a web-based administrative interface. You can log in over SSL again. And then the authentication can either be local, so for test and eval environments, you can just type in usernames and groups, or you can also link it up with an Active Directory as well. So you can pull all your users and groups from your corporate directory. And then we've spent a lot of time working to make sure that we have very efficient data transfer. So under the covers, we're using Microsoft virtual hard disk technology. Those it's basically files on disk that represent the virtual hard disks. And then, what we do to make sure that we're very efficient about data transfer is everything gets compressed during the upload process. And we use client CPU cycles for that as well. So we're always trying to use distributed, CPUs so that we can, keep a real lightweight backend. But anytime like an administrator is uploading a new image or an update to an image, or when the users are uploading their backups, which happens in the background, we compress it all, and then when we send it to the backend, we actually leave it compressed. In the case of backups, usually hopefully you're not gonna access that stuff too often, but you always want it around. But we leave it compressed to save on disk space. And then we assume that people are moving between different types of networks and different types of connectivity, sleeping their system, bringing it back. So we have block level restart on interrupted downloads. So that means, if you were downloading an image or an update or doing an upload, we'll just start from right where we left off next time we see a network connection. So we're very good about just sort of running in the background and trickling this stuff down. And then, one of the great things is at Citrix, we have some neat technology, some WAN optimization technology. We have a system called the branch repeater. And this allows us to provide fan-out infrastructure for the Synchronizer and for XenClient. So you can imagine, initially, something like Windows 7, an image might be, 5 gigs in size. We'll compress it down to save space, but then you still, you don't want to send the same image from your headquarters down to the 30 or 40 people in a branch office. So you can actually use our branch repeater as fan-out infrastructure. And it actually not only does it cache the images locally, but it also does a bunch of WAN optimizations. So we did some neat testing where we set up and simulated a 12 meg link, and we did 100 milliseconds of latency, and we injected some packet loss. And we downloaded a Windows 7 image over this link, and it took 2 hours just without the repeater stuff turned on. And then we turned it on, and it dropped it to an hour. So we got a 50% reduction in the initial download times. And then once the first person's downloaded the image, it's their cached locally. So the next person who came in, it took 3 minutes to download that same image. So now you have it cached locally. You're not pulling it down over the wire. So branch repeater, is this great technology that we have that we've designed to work with XenClient from the start to act as our fan-out infrastructure. We've got 2 ways of delivering images down to XenClient from the Synchronizer. And the first one I call, business as usual. We call it static image mode. And in that case, it's basically taking your existing images that you have, your golden images that you have, and you can upload them. You kind of deploy them on top of XenClient. So we've got Pixie support in the VMs, or people have been using their WinPE boot disks to basically lay down their corporate images, and then you can upload that to the Synchronizer and deploy it out to your laptops. And the nice thing is you can use your existing tools and processes. You can use your existing image. You can use your existing ESD tools. If you're using Microsoft SCCM, for instance, to deploy your apps and patches for all your ongoing management. And, I call this business as usual because we want to make it very easy for people to try this technology and bring it into their environment. We don't want to have them have to change their images or change the way they do things, but we want them to get all the benefits of being able to back this stuff up, to wrap policy around it, kill pill, run multiple environments. You get all these great benefits of taking, what you're doing today, whether it works well or not, you can bring it on top of XenClient. And then and actually I'll talk a little bit about how this works under the covers. So I mentioned that we use VHD files to represent virtual disks. So what happens is when you upload, an administrator uploads an image from a XenClient to a Synchronizer, we're actually taking the VHD file, compressing it, and sending it up to the back end. And then if someone downloads this VM image, what they're actually downloading is that VHD file. Now what they'd see if they could look behind kind of under the covers, the first time they launched that VM image on the local XenClient system, they'd see we instantly create this new little VHD that's initially empty. But as they're making changes like, creating their applications or maybe installing or creating data like PowerPoints and Word and Excel, that little VHD that we created starts filling up. And then, when backup schedule hits, we take that VHD that has all the changes they've made, and we compress it and send it to the back end. And then, as they make more changes on the system, we create another little VHD that takes all those changes and we back it up. And we also merge these things together over time. But we're just using the same VHD snapshot technology that we've had in Xen Server for a while. So we brought that over and we're leveraging it here. The nice thing is, we're just sending the block level changes that the users are making. So we don't have to back up the whole thing. We just have to back up the changes that they're making. And of course, we compress it all as well. And we do this all under the covers. They don't see what's going on. They can be running their VM when the backup happens. They don't notice anything. We just do it all in the background. And then, over time, you can imagine you get a lot of these snapshots. So we have a process that actually merges the old ones together. And that allows us to have very high levels of performance. You don't get a performance hit with having a long chain of snapshots. So the next mode of operation is, we call it dynamic image mode. And this allows you to actually take your desktop image, and instead of having kind of a monolithic image where you have the OS and the apps and all the user stuff all kind of munged together, we can actually separate and use virtualization at every level to kind of separate these things. So you can have the desktop operating system separated from the application layer, and you can have the user profile separated from either of those two. And this allows you to do some interesting things. So we can actually initially deploy an image from the Synchronizer, but then we can also update it. So you can just take that desktop OS layer and modify it as an IIT admin. You can add some more patches or maybe an app that everybody in the company would get. And you upload it to the Synchronizer, and the Synchronizer will generate a delta. And it'll send that delta out to all the laptops. Next time they reboot, they'll move to the new version of the image. And if there's a problem with it, you can actually roll them back. You can actually roll them to any version. So it makes Windows stateless. So suddenly if you have some problem, it's very easy to roll people back. And then you can manage the application layer separately. So you can deliver a set of, kind of corporate site-wide apps as part of the desktop OS image. But then you can have this separate application layer where you're delivering Xen apps streamed or app vapps down to the laptops. And this allows people to customize their application layer, but not lose that ability for IT to have a single image in the back end that they update. And then we separate the user profile as well, and this allows us to just back up the user profile and keep that totally separate from the rest of the stuff on the system. So by kind of moving these apart, you get some nice efficiencies in terms of management. You get the rollback capability. You get a lot more efficient user settings and data backup as well. And so the way this works under the covers is think of it as 3 different hard disks and each one represents those different layers. So there's a hard disk that represents the base OS from IT. There's a hard disk that represents the virtual application layer. And there's a hard disk that represents the user data layer. And so IT can take their disk and they can change it over time and send updates out to the users. So that stuff comes from the back end. The way the virtualized app disk works is we just deliver an empty disk down there, and as the users install their own applications, we store it in that app disk. The nice thing is we've got all those applications on the back end, so we don't have to back up that area. And then the user data disk, as they're making changes, we're backing that stuff up and sending it to the back end. Now, all this stuff is hidden from the users. They just start their Windows virtual machine, and it looks, perfectly normal to them. Under the covers, what we do is we take these 3 hard disks and we smush them together every time they start the system. And so it just looks like the C drive to them. But really what we're doing, using the hypervisor, since we're underneath the operating system, we can dynamically assemble it every time you start it up. And that allows us to move you forward, backward versions. So it's some pretty neat technology, and this is something that really gets enabled by, running on top of a hypervisor like we have. I've been talking a lot about backup as we've been going through, about how it's efficient, how we compress everything. One of the nice things is that the recovery process here, the backups are just happening in the background. You set a schedule for how often you want it to happen. But the recovery process can actually be driven by an end user. So you can drop ship them a laptop, or they can reinstall XenClient themselves in the field. It's very easy to install. They just put in their credentials and point to the Synchronizer in your data center, and then they can actually get a list of all their old backups. They just click, the backup they want and bring it down. Generally, when you're doing recovery, it's very IT heavy, right? They have to reimage a system, help you restore your files, help you with your apps. Here, we take that all away, and we turn what typically is a 2-day operation into, if you're on a corporate network, it's less than an hour generally to completely restore from where you last left off. You don't have to fiddle around with reinstalling apps or, trying to figure out where all your files are, because we actually back up everything that you're doing on the laptop. So it provides this really nice recovery capability. And then, I mentioned up front, we have, one of the things you get with the Synchronizer for XenClient is security policy and protection in the platform. So we have the ability, when you set up an assignment, you basically say, this VM image is available to the sales group or finance. You can also set a bunch of policies. So one is the lease policy that says basically you can run this image offline on the laptop for, say, 5 days. If you don't check back into the mothership with the Synchronizer within 5 days, we'll shut down and lock that virtual machine. You won't be able to access it until you plug into a network to sync back up. We actually had one of our executives, he's running XenClient, and he went on vacation for a couple weeks, and he came back and he said, yeah, I booted up and it said locked on my VM. And he just connected to his wireless network, and he said within about 20 seconds it flipped from locked and it was ready to go. And so, as long as you're still allowed to have that image, it boots back right up. But if your laptop's lost or stolen and someone's walked off with it and they, think they're being sneaky by keeping it off the network, we can actually disable it and time it out after a couple days. And then more aggressively, if your laptop is lost or stolen, we can flag it as lost or stolen in the back end, and then we'll actually actively kill it. If it comes on a network, it immediately checks and does a phone home. You'll see that it's lost or stolen. It'll disable the managed virtual machines immediately. And then on the off chance that the laptop shows up again, you can re-enable it, of course. And then we also have a class of data movement policies. So the ability to block certain types of USB devices, the ability to block access to the audio recording hardware, block access to, you might allow reads from the disk drive, the CD or DVD drive, and not allowed writes, or you can allow both. Networking, control over different types of network connections. So you get all these policy controls that you can twiddle to really lock down. You can get it to the point where you can deliver a virtual machine down, and there's no way to get data off of it other than taking pictures of the screen, right? So you can really lock it down, keep data, secure, still give them their personal environment if you want, depending on the level of security you need in your environment. So what I wanted to leave off with was just giving an update on what's changed since our RC1 release. So we did our RC1 in May at Synergy, and so we've had a bunch of changes since then, and I wanted to talk about some of those new capabilities. So one of the biggest things we did is add 64-bit operating system support in this release. And so I mentioned up front that Xen is a 64-bit hypervisor, and so it's always had the ability to run, both 32-bit and 64-bit operating systems. But now we've done all the work to extend all the, USB support and all the UIs and all the application sharing capabilities so that we can fully support 64-bit Windows 7. So that was a big one. We're seeing a split roughly 50-50 with the customers between running 32-bit and 64-bit Windows 7. We also totally revamped the USB subsystem. So now we fully support internal devices like webcams and fingerprint readers. We actually have a UI that allows you to control connection to both the internal devices and devices that you might plug in. So you can actually virtually yank a device from one VM and give it to another one. And then greatly expanded USB device support. So at this point, we'll support pretty much any USB device you can come up with. iPads, iPhones, iPods, Windows Mobile, Android phones, 3G devices. I mentioned webcams and fingerprint readers, smart card readers. So we've done a ton of work to USB to the point where, we feel like we're going to provide a native USB experience where you can plug in, whatever devices you use and use them in your different virtual machines. And then we also spent a lot of time on client usability enhancements. So we have a whole team here at Citrix that does usability, and we actually did an interesting exercise where we stick people who haven't used the product before, and we give them the manual and give them a laptop and a Synchronizer, and we watch them set it up, and we don't tell them how to do it. And we got a lot of great feedback from that process, and we've incorporated that now into the product. So we've greatly improved the VM upload and download process, as well as providing some cleaner information about download progress and upload progress. We've made a lot of improvements around system boot time, so it's a lot quicker once you hit the power button to bring up XenClient. We've also put in place an in-VM alerting system. So we had the ability to give you alerts if you were in our Citrix receiver for XenClient UI, but people don't spend a lot of time in there. They're generally in their virtual machines, so now we can tell you if you're running out of disk space or if you need to reboot to apply an update. And then we've also done some neat things around our 3D graphics capability that we worked with Intel, where we actually automatically install the Intel graphics drivers. So this just makes it a nice experience if you're running Win 7 or XP or Vista, and you flip the switch and turn on the 3D graphics support. The drivers are already there. You don't have to do anything. They're already kind of slipstreamed into the image for you. Then, one of the big ones is in-place upgrade support, so people that were on RC1 could move forward, both for XenClient and the Synchronizer, keep your virtual machines and your data in place. We did a neat integration. Intel, in their latest version of AMT, has this really neat capability where you can actually do KVM over IP. And it's actually built into the AMT subsystem. So you can actually remote control a laptop or desktop, and it's basically using VNC to connect into the system. And you can not only switch and control the different VMs, but you can also control the Citrix receiver for XenClient user interface. So this is great for remote support, or it's great for doing demos of XenClient over GoToMeeting. You can actually connect in and show people stuff. And then we've also enabled support for Intel extended page tables. So this is actually hardware virtualization assist technology for virtual memory. And this allows us to have faster virtual memory performance, and also allows for some higher security in that area as well. So that's something we turned on as well. And then we spent a lot of time on additional hardware compatibility. So added support for a bunch of different wireless network adapters. As I mentioned, a lot of support around USB devices. We've also added additional laptops and desktops. And the best place to look for this information is on the XenClient site on Citrix.com. You can see our hardware compatibility list, and you can see the latest laptops and desktops that we support. And then on the Synchronizer side, one of the big things that we added is this dynamic image mode support. And we're calling it experimental at this point because it's a new way of doing things. You kind of layer the application, or you layer the VM image. And so, we want to get a lot of feedback from users on apps that they use in their environment and how they want to use this stuff going forward. But this allows you to deploy the initial virtual machine, be able to upgrade it, roll it back. You get the optimized backup capability as well. And we've also completely revamped the web console. So part of our usability testing, and also folks using RC1, we got a lot of good feedback. So we revamped the user and group detail screens. We allow you to actually view and modify the assignments right there. Greatly improved the login experience, so it's very easy now to log into the system if you're using local authentication or Active Directory. We've greatly simplified the assignment process for creating mappings between virtual machine images and policies and users. And then we also added some device filtering support that allows you to see which devices are currently marked as lost or stolen. And then we also did a bunch of scalability enhancements to the Synchronizer. So we optimized data transfer throughput. We also optimized storage of the compressed VM images and backups on the back end. So this allows you to hang even more clients off a Synchronizer system and get lots of scalability. So that's what I had to share today, Doug. A lot of stuff, but wanted to give people an update on where we are and a nice overview and kind of diving down into the technology between XenClient and the Synchronizer for XenClient.
That's awesome, Peter. That's really neat. And I love the new features you guys added in. I sort of always sort of pinged you on this one and gave you a little bit of grief over it, and it was always more of a joke. But you guys now support fingerprint readers too, don't you?
We do. Yeah, I was actually playing around with it. I've got an HP machine, and it's, I actually I don't know how many people use it, but I started using it. It's kind of nice. I don't have to type in my password. It's kind of
it's sort of fun. I mean, the thing about it is that with XenClient, it supports a few different types of laptops, and one of them is that HP model that you have and I have also, and on it has a fingerprint reader and a webcam. And because it has those hardware features, I want to use them. And now you guys fully support that stuff, so that's really great.
Yeah, and that's like, as I said, that's sort of our end goal. We want this thing to just feel like a regular laptop as much as possible. So, we want people to be able to use all the stuff that the OEMs provide on these systems.
You bet, you bet. So now, can people go and get the latest version? What do they do?
Yeah. Just go to citrix.com/XenClient. It's actually, even if you just go to citrix.com, you can find it under the top download section, and you can download the image and install it on one of the laptops that supports it. And as I said, XenClient is free. You can run that on a laptop in isolation, and then we actually provide the synchronizer for XenClient. We allow you to use it for up to 10 users for free, and then after that, we got to keep the lights on. So after that, you'd need to purchase XenDesktop licenses for additional users.
I did not know that. So if I was just a small company and have 7 employees, this is 100% free solution minus support?
Yep.
Oh, wow.
Yep.
Wow,
that's go nuts.
Cool.
And we hope that you keep hiring people. Then you got to come back and buy licenses.
Yeah.
Definitely. If you want to try this in a small shop, it's completely free. And we offer, while we don't, you'd have to buy licenses to get support.
Sure.
There are the online forums and stuff where, especially as people are evaluating the technology, they can come and ask questions and interact with product management and support and field folks as well.
You bet. And it's actually really great then for administrators and for IT departments that, let's say the Citrix group or the desktop group, they can go and actually evaluate this in production, or on their machines and not worry about eval licenses or anything like that. And up to 10 of those guys, which is usually, more than enough licenses for those people.
Yeah. Definitely.
So, and then if it works, which it does, then they can turn around and roll it out to their users.
That's right.
So, well, very good, Peter. I'm very excited about this stuff, as everybody knows, client virtualization. Just today I tweeted again, I love client virtualization, my weekly favorite tweet.
Well, we love seeing it.
Yeah, absolutely. So, okay, Peter, on that note, thank you so much for your time. I'll let everybody go. And again, guys, if you have any questions, there's a lot of stuff Peter went through today, and there's a lot new. And maybe you just have, any type of question you have related to Citrix XenClient, please just email me directly, dbrown@dabcc.com, and I will, Peter and I are going to follow up with an audio podcast just answering nothing but your questions. So I'm really excited about that. So if you guys don't send me questions, I'm going to have to come up with questions of my own. We've already done that. So please email me your questions. And again, Peter, thank you so much for your time.